have to be multiplied. So the question is, how are we going to solve for an equation when the coefficient of theta or x is not equal to 1? That's what I refer to as the multiple angle type. That's what we're going to talk about today. So what we've been working on mainly is if the coefficient is between 0 and 1, then there is going to be no generalization. We'll talk about the generalization in a minute. There will be multiple answers. Then an equation with theta. What we're talking about today is what happens if the coefficient of theta is greater than 1, a generalization is required. There will be several answers. Then an equation with theta. So when we talk about a generalization, we have to come up with a formula. The formula is going to help us calculate all of the angles or all of the solutions between 0 and 2 pi. When you have that coefficient in front of theta, pulling the angles off the unit circle is not as obvious as when you have a coefficient equal to 1. So that's why we have to generate a formula to help us calculate all the different solutions. So for sine, cosine, secant, and cosecant, when we graphed back in Unit 2, do you remember what the period of sine and cosine was? 2 pi. 2 pi. So that's where this generalization is going to come from. So the generalization is going to be some angle plus or minus 2 pi k, where k is an integer. You could have used a different letter. I just chose k. Could have used n. So you will need the generalization for all angles between 0 and 2 pi. So the generalization is just a formula we're going to come up with to help us calculate all of the solutions. That's what the generalization is. For tangent and cotangent, do you remember what the period is when we graphed tangent and cotangent back in Unit 2? Pi. It was pi. So for tangent and cotangent, it's going to be plus or minus pi k. And again, k is also an integer. And again, we're going to need this generalization to calculate our solutions between 0 and 2 pi. So we're going to start by solving these equations very similar to the way that we solved them back with the linear type. Let's ignore this 2 theta right now. I'm just going to replace 2 theta with an x. So first step is I'm going to just replace 2 theta with an x. And I'm going to look at solving tangent of x is equal to negative 1.
Wait, for number 4, is it pi or is it
pi? Pi. Because tangent and cotangent, remember, have a period of pi. I wrote. No, this is for finding all the solutions between 0 and 2 pi. So for number 1, so now going back to the unit circle, where is tangent equal to negative 1? Where am I looking for my solutions? 2 and 4. So what's the angle in quadrant 2 that has a tangent value of negative 1? 3 pi over 4. So x equals 3 pi over 4. And then the angle down here in quadrant 3 will be what? 5 pi over 4. Oh, excuse me, 7 pi over 4. Okay? Now, this is where we're going to bring in this 2 theta that I originally took out. We're going to call tangent, this is the good news situation. For once, tangent's going to be the better case. Tangent up till now, every time I had to deal with tangent, tangents always had twists and turns in it. But when we're solving equations, tangent's actually going to be the good news situation. Because you told me there were 2 angles that had a tangent of equal to negative 1. So the reason why I call this the good news case is use the smallest angle. The one angle will pick up all the solutions for us. We don't have to write a generalization for both angles. So this is what the generalization is going to come in. Remember, I wrote x is equal to 3 pi over 4. What was x originally equal to? I set x equal to what? 2 theta. So now I have to write 2 theta is equal to 3 pi over 4 plus pi k. Like I said, the generalization is a formula I'm going to use to help me calculate all of the solutions. Now we're back. I'm sorry? The generalization? I want to solve for theta. So you want to set up this equation. So what am I going to do to get theta by itself? I'm going to have to do what? Divide by 2. Again, dividing by 2 is the same as multiplying by 1/2. So I'm going to multiply this entire equation I've written by a half. So theta is going to be equal to 3 pi over 8 plus pi k over 2. Like I mentioned, this is the formula I'm going to use to help me calculate all of the solutions. That's what the generalization is. It's a formula I'm going to use to help me calculate all of my solutions.
So why did you pick a small why did you pick 3 pi over 4?
Because this will pick up all of them. 7 pi over 4, you'd end up having to plug in negative integers, and you don't want to have to worry about negative. So now this is what we're going to do. To calculate all my actual answers, I'm going to make a little T-chart. So my first cut, no, that's not my answers. That's the formula I'm going to use to help me find my answers. So I'm going to make a T-chart. The first column I'm going to label K. The second column is the formula, the 3 pi over 8 plus pi over 2 times K. So what you're now going to do, starting with 0, you're going to plug in values for K into this particular formula to find all of your solutions. Remember, I'm looking for angles between 0 and 2 pi. So I can stop plugging numbers in when I start getting angles greater than 2 pi. So start with 0. What happens when I plug 0 in for K? Well, I end up with 3 pi over 8 plus pi over 2 times 0. So what's my first answer going to be? 3 pi over 8. So there's one of my solutions. Am I still smaller than 2 pi? Is 3 pi over 8. Where would, think of your denominator of 8, how am I going to know when I can stop? 16 pi over 8. So I'm going to keep going until I get to an angle greater than 16 pi over 8. Remember, to make your life easier, pi over 2 with a denominator of 8 is equivalent to 4 pi over 8. So now I'm going to plug in a 1 for K. So I have 3 pi over 8 plus 4 pi over 8 times 1. So what's 3 pi over 8 plus 4 pi over 8? 7 pi over 8. Is 7 pi over 8 still smaller than 2 pi? Yes. So I'm going to keep going. So the next number I'm going to plug in after 1 is I'm going to plug in a 2. So 3 pi over 8 plus. Now what's 4 pi over 8 times 2? 4 pi over 8 times 2. 8 pi over 8. So that's going to give me what? 3 pi over 8 plus 8 pi over 8 is 11 pi over 8. Are you noticing a pattern in those numerators? What's happening in those numerators? They're going up by 4. Got to take it out at least 3 times to make sure you see that pattern. All right? So if I was to plug in a 3 for K, what would the next angle be? The next angle would be what? 15 pi over 8. Is 15 pi over 8 still less than 6 pi? I mean 16 pi over 8. Yes. Do I need to go again? No. So notice you've got 4 answers. So now your answers are going to be 3 pi over 8, 7 pi over 8, 11 pi over 8, and 15 pi over 8. And again, if you were to plug these angles back into the original equation, they would work. For example, if I take 3 pi over 8 and plug it in for theta, I have the tangent of 2 times 3 pi over 8 equals negative 1. So when I multiply 2 over 1 times 3 pi over 8, I do know that the tangent of 3 pi over 4 is equal to negative 1. So that's why when you have this number in front of theta, the values are not going to be directly from the unit circle, because now what's happening is those angles from the unit circle, you can be multiplying or dividing, etc., numbers by those theta values, so they're not as obvious. That's why you have to come up with that formula to help you generate the solutions. Again, you only have to do this when there is a number in front of theta. Yes, Tony?
How do you find 4 pi over 8 again?
Just to make my adding of fractions easier, because I know I'm going to have to take 3 pi over 8 and add a pi over 2 to it. So a common denominator would be 8. So I just rewrote that. That just makes the addition simpler.
And how did you get 11 pi?
I multiplied 4 pi over 8, because remember I have to plug in a 2 for k. So when I multiply 4 pi over 8 times 2 over 1, that gives me an 8 pi over 8. So 8 pi over 8 plus 3 pi over 8 is. You will end up with a lot more solutions than you did typically without a coefficient of theta, without when you have a number in front of theta. Okay? Any questions on 1? Now remember, I called tangent the good news situation, because remember, we didn't have to consider the second angle. It's only for tangent and cotangent can we do that. Sine and cosine is going to be for once the bad news situation, because we're going to have to do 2 generalizations and 2 different formulas. Let's take a look at number 2. First of all, you've got this coefficient in front of theta. So again, replace the 3 theta with an x. So right away when I see that number in front of theta, I know this is going to be a multiple angle type. So again, I'm going to write this as 4 sine x plus 3 square root 3 is equal to square root 3. Now what's the first step to get sine by itself? Remember, this is a linear equation, so I want to get sine by itself, so first step's going to be to do what? Subtract the 3 square root 3. Remember, square root 3 minus 3 square root 3, you subtract the coefficients and you leave the number under the radical alone. So 1 minus 3 is a negative 2 square root 3. Then what? And then what? Divide by 4. So sine x is equal to negative square root 3 over 2. So now in the unit circle, where is sine negative? Sine is negative in what 2 quadrants? Where is sine negative? 3 and 4. So what's the angle down there in quadrant 3? Where is sine equal to negative square root 3 over 2? 4 pi over 3. And then in quadrant 4, it's going to be at 5 pi over 3. Unfortunately, as I say sine, this is the bad news. Or you want to call it a bonus. Because the period is different than tangent, one of your angles is not going to pick up all the solutions. You have to do a generalization for each angle. Remember what x was equal to. X was equal to 3 theta. So I'm going to take 3 theta, set it equal to 4 pi over 3 plus. Now because it's sine, is it a 2 pi k I add or is it just a pi k? 2 pi k. Remember, tangent and cotangent, it's just a pi k. For all the rest of them, it's going to be 2 pi k. Now to get theta by itself, what am I going to do? I'm going to divide by 3, or I'm going to multiply by what? 1/3. So theta is equal to 4 pi over 9 plus 2 pi k over 3.
You always take the smaller of the 2?
No, in sine we're going to have to do both. Tangent and cotangent, you do the smaller. Because tangent, for once, is going to be the good news situation. Because again, tangent, you only have to do 1. That's why you want to use the smaller one. So now I'm going to make my chart. There's my k value. My formula is 4 pi over 9 plus. Now remember, I know I'm going to be adding fractions together, so I like to get my common denominator right away. So what's 2 pi over 3 equivalent to with a denominator of 9? That's equivalent to what? 6 pi. Because again, I know I'm going to be adding saviors. You don't want to get common denominators, having to do common denominators over and over again. Start with 0. So now plug 0 in for k. So what's that first angle going to be? The first one's going to be 4 pi over 9. Remember, I need to stop when I get to 2 pi. Where am I going to stop? Kind of have an idea where your stopping point is going to be. When do I know I get to angles greater than 2 pi? 18 pi over 9, exactly. So when I plug in a 1, what's the next angle going to be? 10 pi over 9. When I plug in a 2, so that gives me 4 pi over 9 plus 6 pi times 2 over 9. So what's that? That's going to be what? 16 pi over 9. Is that still smaller than 2 pi? Yes. Do I need to go again? No, because if you notice, once you take it out the third, you can see the pattern. So I know that my next one will give me an angle larger than 2 pi. Like I said, this is your bad news situation. You not only have to consider the 4 pi over 3, you have to consider the 5 pi over 3. So now you have to come up with your generalization for 5 pi over 3. Remember, I've got 3 solutions. To find, you've only found half. So to find the other ones, now you have to take your 3 theta, set it equal to 5 pi over 3 plus 2 pi k. So now, to get theta by itself, what am I going to do? I'm going to divide by 3, or I'm going to multiply by 1/3. So theta is equal to 5 pi over 9 plus 2 pi k over 3. Okay? Like I said, not only do you have to consider the first angle, you have to consider the second. So again, you'll make another T-chart. So 5 pi over, and again, 2 pi k over 3, you already know what the common denominator is, and that's your 6 pi over 9 times k. You guys go ahead and fill out. All right, so let's take a look at the next one. Tell me, is this my good news or bad news situation? Good news, because remember, what I'm going to do is I'm going to replace 3 theta with an x. So x is equal to 3 theta. So I need to figure out cotangent of x plus square root 3 is equal to 0. So what's going to be my first step to get cotangent by itself? I'm going to subtract.
Are we going to need to know the 2 formulas on the test?
Yeah. Where is cotangent negative?
2 and 4.
2 and 4. So now be careful, it's cotangent. You can look to see where is tangent x equal to negative 1 over square root 3 if that helps you. So what are your angles going to be? What's the angle going to be here in quadrant 2? So where is cotangent equal to negative square root 3, or where is tangent negative 1 over square root 3? At what angle? 5 pi over 6. And then the one down here in quadrant 4 will be at 11 pi over 6. Remember, my original equation was not in terms of x. So I now need, again, this is my good news situation, I only need to consider one of the angles. Yes?
How do you know it's a good news situation?
Tangent and cotangent, because the period is pi. One of the angles will pick up all the solutions. So now 3 theta is equal to 5 pi over 6 plus, is it pi k or 2 pi k for tangent and cotangent? Pi k. Remember, tangent and cotangent, it's a pi k. So now to get theta by itself, I'm going to divide by 3 or multiply by 1/3. So theta is going to be equal to 5 pi over 18 plus pi k over 3. So again, this is my generalization. So right here, the generalization is the formula that we're going to use to help us generate all the solutions. That's what the generalization is. That's the formula to calculate all of your solutions. So now I'll make my T-chart. So again, 5 pi over 18 plus, again, because I'm adding fractions, I'm going to rewrite pi over 3 with a denominator of 18, so that's equivalent to 6 pi over 18. What's going to be my stopping point? Well, how do I know when I get to an angle that's equivalent to 2 pi. 36 pi over 18. You guys go ahead now and fill out the T-chart and tell me what the angles are going to be. Let's go over and let's do number 6, just because I ran out of room on the other page. Let's take a look at number 6. So let's take a look at 6. Secant's reciprocal of the what? Cosine. So is this going to be my good news or bad news situation? Bad news. It's going to be my bad news because I'm going to have to make 2 different T-charts, 2 different generalizations. So remember, I'm going to replace the 2 theta. I'm going to let x be equal to 2 theta, and I'm going to rewrite this as 2 square root 3 times the secant of x is equal to 4. What's my first step to get secant by itself? Divide by 2 square root 3. So secant of x is equal to 2. Again, I can simplify 4 divided by 2, which is 2. 2 over square root 3. As you just told me, secant's reciprocal of which function? Cosine. So I want to know, where is cosine of x equal to square root 3 over 2? So where's cosine positive? 1 and 4. So what angles am I going to be looking at? I'm looking at the angle in quadrant 1 of what? Pi over 6. And then the one down there in quadrant 4 would be 11 pi over 6. Remember, I'm going to have to make 2 generalizations. 1 for pi over 6 and 1 for 11 pi over 6. So again, I'm going to have to take 2 theta, set it equal to pi over 6, plus, is it 2 pi k or is it pi k? 2 pi k. So now to get theta by itself, what am I going to do? I'm going to divide both sides by what? 2, or multiply by 1/2. So theta is going to be equal to pi over 12 plus pi k. So again, I can make my T-chart. There's my k. And then my formula that I'm going to use is pi over 12 plus 12 pi k over 12. Where am I going to be able to stop? 24 pi over 12. Because that's equivalent to 2 pi. So start by plugging in 0. So what's the first angle going to be when I plug in 0 for k? It's going to be pi over 12. When I plug in a 1 for k, what's the next angle going to be? 13 pi over 12. What happens if I plug in a 2? I get 25 pi over 12, so I can stop. Okay? So again, right now I've only got 2 solutions. So now remember, I've taken care of pi over 6. Now I need to write my generalization for 11 pi over 6. So I have to take 2 theta, set it equal to 11 pi over 6. Remind me again, is it a plus 2 pi k or plus pi k? 2 pi k. Again, I'm going to divide everything by 2 or multiply by 1/2. So theta is going to be equal to 11 pi over 12 plus pi k. So again, I'll make my second T-chart. There's my k, 11 pi over 12 plus 12 pi k over 12. You guys go ahead and fill out find the other angles. So I want to find, where is tangent x equal to square root 3? So on the unit circle, I'm looking in quadrants 1 and 3. So where's tangent equal to square root 3? X would be equal to what? Pi over 3 and 4 pi over 3. But again, I only need to consider the 1. Remember, my original problem was not in terms of x, it was in terms of theta over 4. So I have to take theta over 4, set it equal to pi over 3. Remind me again, is it a plus pi k or plus 2 pi k? Plus pi k. So now I'm going to multiply by what? 4. So theta is equal to 4 pi over 3 plus 4 pi k. How many solutions am I going to have?
No. 60.
If I have, look at what I'm adding to 4 pi over 3. Am I adding a value greater than 2 pi already? Yes, I'm only going to have one angle. What's it going to be? 4 pi over 3. Because if I plug in 1 for k, would I get an angle larger than 2 pi? Yes. So I only have one angle. So theta is equal to 4 pi over 3. Super good news. Actually, when you see that theta over 4, I know fractions usually scare you. But these are a case where the fractions will give you a lot fewer solutions. Okay? Let's take a look at number 8. Is this a good news or bad news situation?
Very bad.
Bad news. Why? Because I'm going to have to consider what? It's a cosine. So again, I'm going to let x be equal to theta over 3. So 2 cosine x is equal to square root 2. So how do I get cosine by itself? I'm going to divide by 2. So where is cosine positive? Quadrant 1 and 4. So the angle in quadrant 1 where cosine is equal to square root 2 over 2 is going to be at pi over 4. And then down there in quadrant 4 it will be 7 pi over 4. Remember what I said. You are going to have to consider both of those. So let's work on pi over 4 first. So again, bring back in your theta over 3. So theta over 3 is equal to pi over 4. Is this a plus pi k or plus 2 pi k? 2 pi k. So to solve for theta, what am I going to do to this equation? I'm going to multiply everything by what? 3. So theta is equal to 3 pi over 4 plus what? 6 pi k. There's my generalization. Probably don't even need to make a t-chart for this. Yes, Sophia?
How come we don't multiply the denominator by 3?
Because it's 3 over 1. Probably don't need to make a t-chart. So if I plug in 0 for k, what's my first angle going to be? 3 pi over 4. What happens if I plug in a 1 for k? Am I going to get an angle greater than 2 pi? Yes. So I can stop at 3 pi over 4. So now I need to take theta over 3, set it equal to my other angle of 7 pi over 4 plus 2 pi k. So what am I going to do? Multiply everything by a what? 3. So theta is equal to 21 pi over 4 plus 6 pi k. Is 21 pi over 4 already larger than 2 pi? Yes. So I only have one solution between 0 and 2 pi for this particular answer. Okay? That's it. Just 3 pi over 4. Okay? So any questions on that?